Hello everyone, welcome back. In this video, we want to talk about inequalities and what the solutions to those inequalities look like. So when we're working with equations, we have an equal sign between some expressions, and we're trying to find the value of x or a variable that make both sides of that equation the same. When we're solving inequalities, we try to make one side bigger or smaller than the other, depending on the inequality sign involved. Solutions to our equations will usually be a single number or multiple numbers, while solutions to inequalities will be a whole range of numbers that are described using a single or multiple intervals of numbers. So now let's go ahead and look at all the different notations we can use to describe these solutions to our inequalities or these intervals. Okay, so we're starting with this example. We want to describe all numbers that are less than or equal to 4. And so first let's go ahead and describe this using inequalities. And so in our description, we need something that represents all the numbers. And let's go ahead and let x be our variable that represents all the numbers. So we want x to be all those numbers that are less than or equal to 4. So now we need to use the appropriate inequality sign, our less than or equal to inequality sign. And then to the right of that, we'll place our value of 4. And so now we have two statements that are equivalent. Here we have it in words, all numbers less than or equal to 4. And here we have that exact same statement expressed using inequality notation. We're still reading it as x is less than or equal to 4. So another notation that you'll see pretty often, especially in textbooks, is set notation or set builder notation. And it's really just adding a few things to the inequality notation that we just looked at. So we start and end set using these curly brackets. So this curly bracket means we are looking at the start of a set. What follows that first curly bracket that indicates the start of a set is what the elements or things in your set look like. And sets are just collections of these objects. So this is the set of x values, and then what follows what the things in your set look like is a vertical bar, and we read that vertical bar as such that. What follows that vertical bar are going to be the conditions that need to be met in order to make it into the set. So this set is going to be the set of x values such that x is less than or equal to 4. Another way that we can visualize the solutions to our inequalities or these intervals is using the number line. So this is just a single line like the x-axis. And then what we're going to plot on this number line are the x values that satisfy our inequality. In this case, that's all x values that are less than or equal to 4. So maybe 0 is right in the middle. Positive 4 would be somewhere over to the right. And we want to be equal to 4 or less than 4. And so here is how we could express that using a number line. An important note about visualizing these inequalities or intervals on the number line is the kind of endpoint of our interval, if we have one, is either going to be a closed circle or an open circle. Closed circles indicate that we include that endpoint, while open circles indicate that we do not include that endpoint. We can get really close as we want to that value. Okay, and so now we're going to finish it off with interval notation. So how do we use interval notation to describe the set of all x values that are less than or equal to 4? Well, we're going to describe the interval from left to right, and our number line actually gives us a nice visualization of our interval. So we can go as far to the left as we want, all the way to negative infinity, although we can never actually hit negative infinity. And we'll talk about that in just a second. So it's like the start or the far left of our interval goes all the way to negative infinity, and we can go up to all the way to 4, including that value of 4. So when we use parentheses around the endpoints of an interval, that means we can get close to but never actually hit that value. And when infinities are involved, we always use parentheses for the infinity. And these square brackets indicate that we actually can get to and hit that endpoint value. All right, here we see 4 different ways to describe our intervals or solutions to our inequalities. We want to be comfortable with all of them, even though in practice, you're probably only going to use them one at a time. All right, let's go ahead and get a little bit more practice using our different notations. So in this example, we're going to be given 3 different inequalities or statements involving inequalities. And we're going to re-express them using a number line and interval notation. So let's go ahead and start by looking at this statement. And this is an example of a compound inequality. And so we read this as negative 2 is less than or equal to x, which is less than or equal to 7. And so what this inequality is trying to describe is all those x values between negative 2 and 7, where we can include that endpoint value of negative 2 on the left, but we exclude that endpoint value of positive 7 on the right. So let's go ahead and start by redescribing this inequality or this interval using a number line. And so on this number line are our set of x values. Over here to the left, we have negative 2. And then over here to the right, we have positive 7. And so that left endpoint of -2, we are including in our interval. And so remember, we use a closed or filled in circle when we are including a point or an endpoint. And then the other endpoint of our interval is +7. That inequality is not inclusive, so we're going to use an open circle for that value at x equals 7. And so now this interval is all the x values bigger than -2 and less than +7. And so if we connect our two endpoints, we have expressed our interval using the number line. And so we also want to express this interval using interval notation instead of an inequality or a number line. And we can do that pretty quickly here just by looking at our inequality or our number line. So the left endpoint we include. And square brackets are our way of indicating that we are including an endpoint using our interval notation. And so -2 is our left endpoint. The comma then lets us know we're going to look at our right endpoint next, and that's +7. And because we do not include that right endpoint of +7, we're going to use a parentheses around that right endpoint. And so here we have this compound inequality, the x values between -2 and 7, re-expressed using our number line and using interval notation. So now let's go ahead and look at this inequality that is read as x is greater than +1. So let's go ahead and jump right into using a number line to describe our interval of x values here. And so we can think of our starting point at x equals +1. Let's go ahead and put that right there. We don't actually include the x value of +1, so we use an open circle to indicate that. And then this is all x values that are bigger or to the right of +1. And we can keep going forever, so we'll use a little arrow to indicate that. So here we have our interval expressed using the number line, all x values greater than +1. And so what does this look like when expressed using interval notation? Well, the left endpoint of our interval is +1, and we do not include that left endpoint, so we're going to use a parentheses to indicate that. And then we don't really have a right endpoint. We can go to the right forever, and so that means we're going off towards infinity as we head to the right, and we never include infinity as an endpoint, so we're going to use parentheses around that right endpoint of +infinity. All right, so let's go ahead and finish it with this one, which is actually two inequalities kind of put together. We have a compound inequality, all x values between 0 and +1, as well as all x values greater than +6. So we're going to start with our number line visualization of these intervals. And so let's go ahead and start with this first interval of x values between 0 and 1. We're including both endpoints, so we'll use those closed or filled in circles to indicate that. And then other than these x values between +1, we could also be in this set or in this interval if the x values are greater than +6. So we're not too worried about the scale right here, but we do know +6 is to the right of 1, and we don't include +6, so we'll have an open circle there, and then any x value to the right or bigger than +6 will work, so we're going to go off to the right with that arrow. Okay, so now we see this situation is a little bit different than the examples we've seen before, and that we have more than one interval involved in our solution set or in our description. And so we're going to have to use multiple intervals and join them together when we use our interval notation to describe these inequalities or these visualizations from the number line. And so our first interval is this closed interval from 0 to 1, right? We include both endpoints, so we use square brackets to indicate that. And then our second interval here is starting with a left endpoint of 6 that is not included and goes on forever or off to infinity to the right. So that second interval is from 6 to +infinity, not including either endpoints. And the way we join two intervals together is with a capital U, which is the union symbol in set notation. So this is the closed interval from 0 to 1 in union with or joined with the open interval from 6 to +infinity.